Hello, I'm Captain Dan Kiggins with NASA's Langley Research Center. Today we will share one vision of the future of automation in aviation by one of its architects, Dr. Kyle Ellis, who will join us momentarily. And then we'll hear from Chad Stephens, who was the lead researcher during our 3-year study on the role of humans in an increasingly automated environment. I'll ask Kyle and Chad what attributes they observed in the most successful crews and what skills future pilots will want to possess. First, let's welcome Dr. Ellis. As someone who is intimately involved in the development of our airspace and the vehicles that will occupy it, I'd like to ask, what are the top 3 emerging technologies our crews can expect to see in the time frame for their introduction?
Big data analytics is a real buzzword these days, and there's a reason for that. The digital transformation of aviation has been going on for a while, and this has created new possibilities regarding safety data monitoring and analysis. We're working on machine learning algorithms that allow us to sort through incredibly large and diverse data sets, much faster than we do currently, to assist in the identification of hazards. This helps us improve our proactive safety strategies by helping us turn data into information and actionable intelligence, which is especially important as these data sets continue to grow exponentially. We're also developing predictive and prognostic technologies that allow us to take deep analytic dives on data to generate educated glimpses into the future and identify potential hazards, especially when incorporating several data streams such as weather, traffic, aircraft state, and schedule. And lastly, not only are we developing means to quickly identify hazards and manage risks, but we're also looking to develop means to tap into an even larger data set, data that allows us to see when and how our pilots have saved the day, especially when they encounter off-nominal events. We're conducting research on how to capture that data and incorporate it into process improvements and new technologies designed to help pilots do what they do best, safely get us to where we're going. All of these activities we're working on now, with tangible demonstrations with our partners happening as soon as next year. You're all aware that integrating new technologies, especially in commercial aviation, takes time. So we're not only maturing new technologies, we're coordinating these efforts with the FAA and standards development organizations to streamline that process to get the right tech in the right hands sooner rather than later.
Kyle, it's safe to say we can anticipate the introduction of unmanned vehicles or UAVs at some point. What research is being done to integrate them into our airspace, and how do you anticipate them interacting with manned aircraft?
It's safe to say we're in the midst of a second renaissance of aviation. Not since the introduction of the jet engine have we seen such a dramatic increase in new vehicle types and number of operations. The applications for aviation is expanding rapidly, with new entrants like UAS performing local services, to the expansion of commercial operations to service the growing traditional aviation market. This presents challenges that require us to evaluate how we manage the operations in the airspace and assure the safe and equitable access to it. NASA is evaluating technologies to help manage the risks introduced by the new entrant community. From active safety technologies on board the vehicles to help ensure they only fly where they're permitted to safely perform their function, to the advancement of air traffic monitoring and management systems to track and guide UAS vehicles to provide situational awareness to crewed aircraft and air traffic control, especially within high-risk areas. There are even some effective technologies to defend against rogue aircraft flying where they're not allowed, such as near an airport or a stadium. The FAA's InfoCentric NAS and NASA's Sky for All progressive visions for aviation transformation outline how the digitization of the National Airspace System will allow us to leverage new technologies and enhance our processes to operate and manage all forms of aviation safely, efficiently, and sustainably in the skies above us.
Well, thank you, sir. And as we can see, a rise in automation and the desire for efficiencies is predictable. So with this in mind, NASA conducted a 3-year study both here at Langley and at the Boeing Flight Training Academy in Miami. We recreated an American Airlines 737 flight deck, and using 36 American Airlines pilots who then flew 6 scenarios into the Charlotte airport, each involving some degree of the failure of automation, be it either ground or flight. The goal then was to identify and quantify what we call the human contribution to safety. By and large, pilots capture errors 157,000 times more often than they create them. So it's very reasonable for pilots to wonder what role you as pilots will play going forward, and equally safe to say it will differ from the present and certainly from the past. Chad Stephens was the lead researcher during the study. Welcome, Chad. After extensively observing crew performance, I'd like to ask what attributes were notable in the most successful crews, and secondly, how do you envision the relationship between pilots and automation going forward?
Hi, Captain Kiggins. These are excellent questions. The NASA System-Wide Safety Project supports research to better understand the role of humans in aviation safety, focused on how to study operator-resilient performance using flight simulation methods. Building on prior NASA efforts investigating procedural non-adherences during area navigation standard terminal arrivals, a high-fidelity commercial aviation line operational simulation experiment was designed and conducted at NASA Langley. The focus of the study was on how flight crews anticipate, monitor for, respond to, and learn from expected and unexpected disturbances during these operations. 12 commercial airline flight crews from American Airlines participated in the experiment at NASA Langley Research Center. During these recent studies on human contributions to safety, I recognized several characteristics and skills in flight crews who were successful despite typical off-nominal occurrences. Acceptance of one another as members of a team was evident in crews who anticipated and resolved issues designed into the scenarios. Also, pilots who communicated expectations for a flight and continued to do so during the flight were able to work collaboratively. Notably, the American Airlines crews employed the green, yellow, red status to indicate to one another when they needed backup or were recovered from high workload, which enabled better overall performance by the flight crew. A vision for the relationship between pilots and automation, which I believe holds great promise, is one which evolves beyond a substitute or simply automating pilots out of tasks. Furthermore, I expect that automation can do more than augment pilots as a tool that provides enhanced capabilities and insights. I expect that we will see automation which enables cognitive collaboration. What this means is that the strength of the human is leveraged against the capacity of intelligent technology. The strength of the human pilot is apparent every day if we consider the number of times pilots produce safety, which is referred to as airmanship. The ever-increasing complexity of the airspace requires that airmanship continues to advance in collaboration with enabling intelligent technology.
Well, Chad, thank you for that. And finally, would you be willing to comment on a persistent rumor that NASA is working towards eliminating the role of the pilot?
The direct answer to that question is no. NASA is not working towards eliminating the role of the pilot. Pilots are and will continue to be vital to safety in aviation operations. We recognize the value of the human to adapt to circumstances which cannot be foreseen and to perform such that the safety of the operation is maintained for the flight which they command and other flights in the shared system. NASA is conducting research on fully autonomous vehicles, and system-wide safety is contributing to that research by examining how to redefine the role of the pilot for certain types of missions or vehicles. New concepts in system safety thinking have emerged to consider not only what may go wrong, but also what can be learned when things go right during commercial flight operations. Taken together, these complementary perspectives form a more comprehensive approach to system safety thinking. However, a need exists for research methods to enable a better understanding of the human contributions to aviation safety through both failures and more frequently occurring successes. The human contribution to safety, as we refer to it at NASA, is intended to capture and describe what human flight crews routinely do right. American Airlines has also been pioneering efforts to capture operational data about these kinds of crew capabilities through its Learning and Improvement team. American Airlines lit navigators are accomplishing work in these areas with observations and shop talk interactions, and our team at NASA is working with American Airlines lit members to examine data captured in our experiments to extract more knowledge and enable aviation safety in the United States and around the world.
Well, thank you, sir.